Okay, then we go to the next speaker. Michal is in our midst now, and he is responsible for working in the PNSC network, or the Poznan Computing Center. Sorry. Yeah, you can. And he will say something about the PIONIER network in Poland. The floor is yours, Michal.
This way?
Yeah.
Can you hear me?
Perhaps
Okay. Move it. I think this is slide back. In the middle?
Yes, that one.
Jesus. Just can I go? How can I go back?
This is back. This is forward.
Are we going forward? Oh,
Yes.
maybe just press home here. Yeah. Okay. So one press, one slide, right?
Yes.
Okay. My name is Michal Pryzbylski. I'm the third on the list here. This article is originally, this presentation is based on an article from my superior, Mr. Stroiński, who is not here, unfortunately. I'm replacing him for you today. And I'm going to talk to you about the PIONIER network, how we build it, how we develop it, what are our beliefs, what are our experiences, and how this network and how the process of building national optical network can influence Europe. First of all, fascination of fiber. We are fascinated by fiber. We use it from 90 in buildings, campuses, metros. It proved to be a good solution for Ethernet, ATM, POS, DWDM links. It's cost-effective, usable by science, and many networks are already using it. We have an excellent presentation from CESNET. Eric sits here. He's going to say something about it very soon. And also people in US, Canada, Switzerland has own DWDM network on own fibers now, at least leased fibers for long-term lease. So we see quite strong movement into all optical networking. Maybe it's not all optical yet, maybe it's now electrical, but one day maybe it's going to become all optical. We think that this all is going to move into the area of what we call all optical Europe for mobile Europeans. This is kind of idea that brings together all the network technologies in the core, in the access, all together that with new way of data transmission, that voice comes into IP, data comes into post links, and then we have this video conferencing, and we have Wi-Fi, free space optics, we have fiber optics, DWDM systems. This all allows to predict us, even that the situation in the market now is not very good, we can predict that in the future we will go forward with these technologies and we get optical Europe for mobile Europeans. Based on those assumptions, led us to define the project that was accepted by the Ministry of Science in 1999. It was called PIONIER, Advanced Applications for Information Society. In 2000, we have the first testbed. Testbed was with DWDM equipment. We have presented the results of the testbed on TNC in 2001. It was the same conference, perhaps you saw it already. And in the third quarter of 2000, we had this project accepted, and we had the tenders running, negotiations with telcos for laying fibers. It was the base assumption. We have to lay fibers to build something special. And this time it was maybe somehow controversial, but we saw other networks following that closely. JustNet, SafeNet, again, the same examples. And in two phases, in 2001, 2002, we have spent almost 30 million of euro for building own fibers in cooperation with industry. And in this moment, we are installing 10 gigabit Ethernet on DWDM links, and that would be 10 gig switch network. Just for some facts, in this year, very soon, we will have 16 months connected on own fibers, and at the end of the next year, we're going to have all months metropolitan area networks connected with own fiber. would be something like 5,000 kilometers of the fiber. That's the topology of the fiber. You could see, oh, there's the laser. You could see all red links already deployed and ready to work. There's, however, no equipment yet. It's going to be there next month. On the green ones are being finished now. So these spans are going to be finished very soon. And we'll be able to connect from here, from this city on the east, close to Belarus, Białystok to Warsaw, Krakow, Poznan, up to Gdańsk. And this is all our own fibers. The yellow ones will be developed in the future, deployed as the funding allows, as the money is there. How we build them, that's very interesting. I think for the first time, it's a much different situation than, for example, in US when networks gets fiber from industry, or not really fiber, just lambdas or parts of the cross connects. In Poland, we build it together with industry. We get telcos. We share the same cable with multiple fibers. Some of the fibers are theirs, some of the fibers are ours. And we have average of 16 fibers, sometimes less, sometimes more, but average is 16. We have 4 fibers reserved for national backbone, 8 for regional use. These are standard mode fibers. And then we have 4 times G655, which is non-zero dispersion shifted cable for long-haul transmission, perhaps for JAN 2. We don't know yet. This is for long-haul transmission. And we have built the network in such a way to allow for high-speed transmission, 40 gig and more. So average span length is about 60 kilometers. This will allow us to increase the network speed in the time as we grow. But the problem was that the local loop construction is difficult. That's why the green spans that I show you are not yet deployed fully, because we have fiber in the field, outside the city, but in the city, we have to wait 6 months for the permission. And if we started at the beginning of the year, now we have the permission already, but the works can just start. So it takes a long time. Why we build that? We build that because we have demand. We have demand from academic internet. Now we have 2.5 gig to JANT. It's being filled up right now. National backbones are already filled up. 10 gigabit per second is going to be deployed in October. So it will be the second, I think, after Italy. We're going to be the second. Surfnet is opting for 10 gig. We're going to be the third one to apply for that. So there is a need to increase that speed. Between months, we have 622 megs, and we need more because it's already filling up. In the near future, we think we need n times 10 gig, because if you got right users, then you have to deliver right bandwidth. High-performance computing centers, they use fiber channel, gigabit Ethernet, 10 gigabit Ethernet, and different projects. We had the national project with Sun, building a cluster of computers connected with 1 gig Ethernet. 3 sites, it's already 3 gig in the backbone. SGI cluster, also with industry, 6 sites. Another project being prepared requires more and more sites to be connected with dedicated channels. And we need our own fiber and own DWDM system, at least something like this, to connect all these places. European projects. So far we use Atrium. I think you saw a couple times already. Juniper was showing that, JANT was showing that. The Atrium is connected 622 megabits per second with CCC connections of a JANT. We are lucky that this is in Poznan. If this was in Warsaw, we would not provide it now because there is no bandwidth. But as soon as we deploy more, then we can easily give some bandwidth to Atrium, 6net, VLBI, which is radio telescopes, CERN, which is Atlas from the Large Hadron Collider, and new 6 framework program projects. They really require bandwidth. Otherwise, the cooperation is not possible. How we want to do that? First of all, we start with 10 gigabit Ethernet at a very intermediate stage. We put 10 gigabit Ethernet switches, and we operate VLANs as we will operate lambdas in the future. It's different technology, but the management should be similar. We learn how to manage, how to deploy services, and we deliver them in the form of 10 gig Ethernet. Later on, we plan to go with DWDM system. I would say this one is already being deployed. This one, our hopes to do. So we would like to have DWDM system with 40 gigabits per second lambdas, optical switches with GMPLS. I know it's quite in the future. We had some research done in this area, and they say that the market is not there, so the equipment availability is not there yet. But we want to deploy, using these devices, we want to deploy optical VPNs for internet, high-performance computing network, government networks, and for European projects, if necessary. And of course, we need to develop better MANs to cope with that requirements. This is a short introduction of the 10 gigabit Ethernet network. So this is June this year, so next month. These links are going to be used. We put a central router in Poznan to exchange traffic with Zand. Then the node will be looking like this. The computer is really slow. Then we put black diamonds in all of these locations. And yeah, you have to wait a little bit. And after these black diamonds are installed, we connect them to remote sites that we don't have fibers yet, but we have already ATM equipment. And we need to provide ATM over gigabit Ethernet, over 10 gigabit Ethernet connections. And these points will be connected to the nearest points of presence for PIONIER network. This is a target network. I'm not going to be long on that. Target network is going to be DWDM with multiple lambdas. I show you why and how the lambdas would be in the future in the next slides. Academic internet. This is the demand for academic internet. It's 22 months connected with the black lines, 10 gigabit Ethernet, blue lines, it's a 10 gigabit POS, and the yellow lines are dedicated 10 gigabit POS for different purposes. Then this network is connected to Zand via say a double router, whatever, redundant router, which will be located somewhere in Poznan, if possible. And this router will have 40 gig connections to all sites, to the major MAN sites in Poland. So you could see the ones that are here on the bottom are marked here red. So every of these locations will have direct 40 gig connections with a backup lambda for security. Another requirement goes 10 minutes. I try to be faster. Another requirements come from high-performance computing and IST projects. So far, just to show you a few, high-performance computing network, Gdańsk, Poznan, Warsaw, Wrocław, Kraków. They're located over there. They need dedicated connections, 10 gig, 40 gig. In the future, the demands will grow. Progress project, 3 sites. Astronomers from Torun to Dingalu in Netherlands. 1 lambda, at least 2 times 1 gig. That's what they need. Atlas, CERN, 2 locations. I'm not sure exactly what's the requirements now, but somebody said 60 gig yesterday, or day before yesterday, somebody said 60 gig. Right now they need less, but maybe in the future they need 60 gig, so we have to deliver. And SGI project and possible others. So these are already lambda requirements for the network. We'll deliver the service right now with Ethernet VLANs. So we maybe give everybody 1 gig for connectivity. But in the future, we need lambdas. And we need to manage. We need to protect. We need to reroute as necessary. So if we develop that network, this way we'll have a lambda POP. I just have to skip a few slides because time is short. The economy. We built that network because we believe, and we have tried this, tested, that the economy is there. It's much cheaper for us. For example, when we ask for 622 megabits per second channels for all these months, I think this is really interesting. We got 5 million euro per year, the price quote. If we go for 2.5 gig, we never got the quote, but we believe it would be like twice. You make a capacity 4 times, the cost should be twice. So it's 10 million euro per year. if you go for 10 gig, as we deploy now, would be 20. Another factor 4 and 2. So with 20 million euro per year, all the fiber, building all the fibers, and deploying 10 gigabit Ethernet networks on that with these black diamond switches and DWDM, like cheap DWDM underneath, and paying the maintenance, it's less than 60. So the investment return is in 3 years. That's why we build it. And now we have the full flexibility. Our fibers, our equipment, we can do whatever we want. And this is only for 1 lambda. Okay. And what are the opportunities for the future? The opportunities are as follows. E-regions. We have 2 e-regions proposals already ongoing. One is with Germany, and the other one is with Czech Republic. When we have, or we will have very soon, the direct cable connections to their networks. And there is a whole area of cooperation opening on the eastern border. We can connect to Russia, Kaliningrad region, Lithuania, Belarus, and Ukraine with cables. It's just up to those countries if they want to participate. And of course, with these cables that we have in here, we can go directly from those countries to Zand. And also offer Zand to be there. What is the region is written here. I'm not going to read it. It's short time. You can download from the presentation later. Oops. Yeah, Porta Optica. This is how we call this area for cooperation with the East. Porta Optica is the concept of the project for cooperation with those Eastern countries. And yeah, we think that PIONIER could be a nice example of European Network for Advanced Services. There are resources all over the world. There are grids. There are large bandwidth capacity requirements. And you can see here, I just listed some of the projects: TeraGrid, TV distribution grid, X content, which means whatever content grid. These projects are bandwidth demanding, and they need to have dedicated bandwidth as well. Global Internet is also, now we see, not global, European Internet. Zand is thinking about going maybe multi-lambda between sites, because they need to have n times 10 gig now. If they want to support Jive, even with the CCC connections, they need to have n times 10 gig between Zand POP there and Netherlands. So there is area. How to build those networks? We guess that there will be one internet, still one internet. But in different countries, we will develop grids. We can do computing grid in Poland. We can do computing grid in Czech Republic. Video grid, education grid. They need to be connected. We'll have some points of presence for those grids. If user is inside the grid, the red line, then the user will be able to communicate just via the grid. But if the user is outside the grid, it has to be through the global internet. And we need to prepare, eventually in Zand 2, something what we call distributed grid gigs, gigabit internet exchange. So this place here would be like distributed POP, when all grid services will be present. We can see in many presentations today and yesterday that there are some authentication portals, user access portals. They have to be located somewhere near here to let people access those grids. And we need to have multiple distributed grids exchange points in the network, besides normal internet that is going to be always there. Nobody talks about replacing that. But in the parallel, we have parallel structures with the points of presence. What are the beliefs? NS will go multi-lambda. Now Czech people are testing 10 gig. In 5 years, you will be testing n times 40, I guess. SurfNet does the same, not to look far. Grids are everywhere. More and more grids, and the grids have to have dedicated networks. Wireless technologies are becoming more and more common, and therefore more and more people will use internet all the time. you sit here, everybody has a wireless. But next generation of wireless network will be faster and broadband. Therefore, CarNet we need to have a new network to deliver you a right service. And NRES will contain, of course, metropolitan area networks, which possibly will be uniquely managed. There are many projects now we could see yesterday, Grande, Garden, going in the same area of having multi-domain, somehow multi-vendor networks, but perhaps with a unified management. Ethernet will go everywhere. It's now not yet in telcos world, but it's coming there. And the world of NRENs and world of telcos are coming together. They implement gigabit Ethernet that they wouldn't do 10 years ago, or 5 years ago, I would say. They wouldn't ever think about Ethernet, but now they think it's maybe feasible to do. And we were employing telcos technology to transport data. And now it's all mixing up. They use our technology, we use their technology, and it's all becoming Ethernet. And IPv6. IPv6 will trigger new applications as well. Everything will be IPv6 very soon, I guess. We're running out of IPv4 addresses. So these are beliefs, and this is the last slide. Thank you very much. Questions, yeah.
Thank you very much. There is time for one question. I think Poland is very advanced in at least seeing the number of fibers they have. It's amazing, so it's good.
The money is still a problem.
Did you ever consider using CWDM instead of DWDM, and why did you make the decision to go to DWDM?
We did maybe look like we made decision. We'll choose the most feasible technology. If CWDM will be able to run 300 kilometers, because I think that's the largest distance, without 3R regeneration, then we can go for CWDM. And if it can go 40 gig, then there's no problem. It's just the question, can it go as far as you want to go? Can it go 40 gig, possible in the future? We are not telcos, we need to count our money. Okay. So from one point, okay, we can buy CWDM, which would become obsolete in 2 years. On the other hand, we can buy just one lambda with good DWDM system, and then add lambdas as we go. So that's a choice for everybody. But generally, I would say WDM. That would
Thank you.
One question. Thank you, Victor.
Okay, thank you again. So I said earlier, we're now going